Hello students, this is Sudeep Yadav from Spectrum Chemistry, and students, if you are first time visiting to my channel, so please like and subscribe my channel and press the bell icon to get a best explanation of NCERT book class 10th subject science, and in science we will discuss chemistry. And students, if you are watching this video, so please go to my playlist and watch the previous first part of this chapter, that is metals and non-metals. And students, today in this video, we are going to discuss about the chemical properties of the metals. And in the previous video, we have discussed about the physical properties of the metals as well as non-metals. So let's start, students. In the today's video, we are going to discuss about the chemical properties of the metals. So let's see. So first of all, students, what kind of the chemical properties of the metals? So let's see. Some of the chemical properties of the metals are listed below. These are easily corrodible, means metals can be corroded. Okay. Now next, can lose electrons, means they can lose the electrons during the bond formation. Why? To complete its octet, and through which they can get the stability. Okay. Now third point, form basic oxides. And students, why we are saying the metallic oxides are the basic oxides? Actually, these are the basic oxides due to the some reasons that when you will be dissolve the basic oxide inside the water, they will convert into their respective base. So that is the reason behind it. We are saying these are the basic oxides. As well as if you will be see the metallic oxides, so they having a basic nature. Okay, because when they will interact with the acid, they will convert into respective salt and water will form. So that is the reason behind it. These are the basic oxides. Now have low electronegativities, means if they are the electropositive, actually metals are the electropositive, but somewhere they are having a very low electronegative characteristics also be. Okay. Now they are the good reducing agent. They are the good reducing agent because metal having tendency to lose the electrons. So means they will provide the electrons to reduce to the another element. Okay. So that is the reason behind it. They are the reducing agents. Now come to the next property of the non-metals, that is the chemical properties of the non-metals. So some of the chemical properties of the non-metals are listed below. These are the number of the electrons in the outer shell is generally 4 to 8. Okay. Now next point, easily gain or lose valency electrons and form acidic oxides. So similarly, as we have discussed in the case of the metallic oxide, they were the basic oxides. Similarly, here if you talk about the non-metallic oxides are the acidic oxides. Why? Because if you will be treat the non-metallic oxides with the water, they will form their respective acids. Suppose carbon dioxide gas, when dissolved inside the water, it will convert into carbonic acid. Sulfur trioxide gas, when dissolved inside the water, it will convert into sulfuric acid. So these all oxides are the non-metallic oxide. Actually sulfur is a non-metal, carbon is a non-metal. So when we are dissolving them inside the water, they are converting into their respective acids. So that is the reason behind it. These are the acidic oxides. Now high electronegative elements means they are having the tendency to gain the electrons. Okay, pull the electrons due to the small size. Okay, so that is the reason behind it. Now next, great oxidizing agents means they are having the tendency to gain the electrons from the another elements during the bond formation. Okay, so means they are oxidizing to other one. So these are the great oxidizing agents. That is the reason behind it. Okay, now the next property, that is the important property. Okay, that is reaction with oxygen, means metals reaction with oxygen. How the metals will react with oxygen? So let's see, students, most of the metals form the respective metallic oxides. when reacting with oxygen. So if we talk about general reaction, so what is the general reactions? Metal plus oxygen, and it will convert into metal oxide, and this metal oxide will be basic oxide. Okay, now one by one we will start discussing about the reactions of the metals with the oxygen. So first metal we have, that is potassium. Okay, so reaction of potassium with oxygen, that is potassium metal forms potassium oxide when react with oxygen. So you can see in this equation the potassium is reacting with oxygen and it's converting into its respective oxide. And here is a very important point we can see here, that is the vigorous reaction. Means when the potassium will react with the oxygen, this will be the very fast reaction. Okay, so means the kinetic, if we talk about the kinetic energy, if we talk about the speed of reaction, rate of the reaction, okay, this is the rate of the reaction. So the rate of the reaction very fast in the case of the potassium. Why? Because it is the most reactive metal. This is a very most reactive metals. Okay, so that is the reason behind it, they will be so a vigorous reaction. Okay, now next, reaction of sodium with oxygen. So sodium metal forms sodium oxide when react with oxygen. Why? Because it is also another most reactive metal, that is sodium. So when the sodium react with oxygen, it will convert into sodium oxide, and this is also be a same reaction like the vigorous reaction. Okay, but now in the next line, just below the equation, you can see a very important point. Lithium, potassium, sodium, etc. are known as alkali metals. Alkali metals react vigorously with oxygen, okay, due to their reactivity. Okay, now to prevent this oxidation, means when they are reacting with oxygen, so there is a oxidation is going on. Okay, so to prevent this oxidation, sodium and potassium are stored under kerosene oil, not in the water. Okay, not in the water. We are placing lithium, sodium and potassium inside the kerosene oil. Why? Because their reactivity, and if there is a no oxygen supply, so it means they will not react. Is it clear? So due to the reactivity of the sodium, potassium and the lithium, we have to store these all metals inside the kerosene oil. Okay, now next, reaction of copper metal with oxygen. So copper does not react with oxygen at room temperature, but when burnt it in air, it gives oxide. Okay, and the oxide is a cupric oxide. But students, suppose if we talk about, suppose an example, if there is a envelope of copper, okay, so here if you are burning it from the outside, when you will be expose it over the Bunsen burner, okay, so a black layer of the cupric oxide will form outer surface of the envelope of the copper. Okay, but suppose if we talk about the inside, okay, if we talk about the copper envelope, and you will see, when you will be observe the inside of the copper envelope, so there is a pink color will appear. Why? Due to the formation of the cuprous oxide. Okay, so here is a two kinds of the compound will form. Okay, not only the one kind of the oxide will form, here is a two kinds of the oxide will form, that is the cuprous oxide as well as the cupric oxide. Okay, now next, so why there is a cupric oxide and inside is a cuprous oxide? Because oxygen supply. Okay, if we talk about the outside, there is a sufficient supply of the oxygen, so means it will be converted into the cupric oxide, and inside the cuprous oxide. Okay, now next, silver, gold and platinum do not combine with the oxygen of air even at high temperature. They are the least reactive, that is the reason. Okay, so please note it down. This is a very important point, that is silver, gold and platinum do not combine with oxygen of air even at a very high temperature. Okay, so means they are the noble metals, you can say. Okay, now reaction of magnesium with oxygen. So as we have already learned in the first chapter, the reaction of the magnesium with the oxygen, that is the magnesium oxide formation. So what was the activity? First of all, we having the need of a small piece of the magnesium ribbon, and we will rub it through the sandpaper. And why we having the need to rub it through the sandpaper? Due to the magnesium carbonate, that is the layer, that is the impurity which will be formed on the surface of the magnesium ribbon. We have to be clean it. Okay, and then we will hold it through the tongue, and then we will be expose it over the flame, and it will start burning. And when it will be burning, it will be burn with a special kind of the flame that is known as a dazzling flame. And the color of the compound which will be formed after the burning of the magnesium ribbon, that is the magnesium oxide, and the color of the magnesium oxide will be white powder. Okay, so this is the magnesium oxide. So here is another reaction we have discussed. Now reaction of iron with oxygen, how they will be react with the oxygen. So let's see students, iron metal does not burn in the dry air even on strong heating. In moist air, iron get oxidized, but in moist air, iron get oxidized to form the iron oxide, that is known as the ferric oxide. Okay, or this is also known as a rust. Okay, so this is the special point about the iron. Now reaction of aluminium with oxygen. If we talk about the surface of the aluminium metal, is covered with a thin layer of the oxide. This is very important point, that helps protect the metal from attack by air. Okay, so normally aluminum metals does not react with air. Aluminum will burn in oxygen with a brilliant white flame. This is very important point. Okay, aluminum will burn in oxygen with a brilliant white flame to form the trioxide aluminum, that is also known as the aluminum oxide or aluminum trioxide. Okay, sorry. So this is the reaction, and this is also another specific case. Okay, now next reaction with water, how they will be react with water. Metals form respective hydroxide and hydrogen gas when reacting with water. So here is a general reaction, and about this property of the metal, about the examples for this kind of the reactions of the metals with water, we will discuss in the another video, that is the next video. Okay, but in this video we have to be discuss more about the metallic oxides, that is the amphoteric oxides. Many metals such as copper, zinc, tin, lead, aluminum and the beryllium form amphoteric oxides or hydroxides. And what is the amphoteric oxides? Means those metallic oxides which can react with acid as well as the base. Means they can react with acids as well as the base. So means they having the dual nature. Okay, so this kind of the metallic oxides are known as the amphoteric oxides. So metal oxides which react with both acids as well as the base to produce salts and water are known as amphoteric oxides. Amphoteric oxide includes lead oxide and the zinc oxide among many others. Okay, so here you can see the example, that is the zinc oxide when reacting with sodium hydroxide, they will converting into sodium zincate and water is forming. And similarly when we are treating the aluminum oxide with the base, that is the sodium hydroxide, it will convert into sodium aluminate and water is forming. Both are the salts. So I hope students you must have enjoyed this video. So thank you students.